Great. Good afternoon, everyone. My name is Ewen Lim. I am with Athena Dynamics. Now, today's topic is called turning your black box into a white box, how you can benefit from next generation binary analysis. Now, before we get started, we're really going to have some fun with this one. Really want you to, as an audience, get participated into this seminar. So if you have got an app in the Google Store or the Apple App Store, and you would like to actually have it checked right now, send me the link. What we'll do is we'll look through the scan reports together after this short presentation. You can reach me at ewen.lim, EWEN.LIM, at athenadynamics.com. Again, EWEN.LIM at athenadynamics.com. We'll do a scan of several apps and share the findings with you after this. Please do not be cheeky and send me apps of your competitors, which has happened in previous cybersecurity summits before. So we're going to begin by having a look at how some of these new source code review tools work. Okay. For sheer example's sake, I've chosen one called Solar App Screener, okay, which is a binary SAST tool. It's as simple as entering the Lightning browser, for instance, into the Google Play Store. Click on the app. Once you get the app, copy, get it into the App Screener tool. Once it's in, start the scan, and you can see on the left, works super fast. Now, before we get started, just a little bit about the landscape that we have today. Firstly, lots of challenges because there are lots of claims. Several companies in this space say that, hey, we are able to do true binary SAST without source code. Is this true? Can they really do claims of binary SAST if indeed they typically need debug info in order to actually pack back to source? Or are there technologies outside which allow you to actually do this, to give you true binary SAST without source code? Have a think about that for a minute, okay? Now, a bit about the landscape that we have today. Three main challenges that we have. Firstly, apps are a big line of defense. With the move towards cloud, smart nation, digital transformation, very often the only line of defense is software itself. Number two, with the push towards faster and faster CI/CD, you have very, very little time in order to do proper code analysis, to discover vulnerabilities that you might have. And finally, many cybersecurity experts, including Interpol, Europol, believe that up to 80, even 90% of successful attacks are actually done through your applications. So where do these vulnerabilities and backdoors actually come from? Firstly, poor development culture, lack of time, as we've said before, as well as legacy software. Now, to show you how exactly technology goes through leaps and bounds instead of an actual linear curve, I wanted to pick one of my favorite quotes of all time, which is by the inventor of the common commercial car today, and that's Henry Ford, okay, from which we get the famous car brand, Ford. He said, if I had asked people what they wanted, they would have simply said faster horses. And with that type of mindset, okay, what Henry did is create the first commercial car, the Model T Ford. And of course, in the last 100 years, we've got Teslas today, which are powered by electricity, and which are going autonomous all around the globe as well. And likewise, the same idea can be applied to SAST technology. What many technologies in this space do is automate code reconstruction technology that was previously available only to highly trained engineers, mathematicians, because they're doing reverse engineering. And what several inventors have been able to do in this field is actually reform the static application testing onto executable files of applications and map the reconstructed source code so that it reveals your vulnerability, reveals your backdoor. Okay? And how have they actually managed to automate code reconstruction? Well, before we get into that, a couple of basic terms that we're talking about. Today, it's really popular in our woke culture, I guess, to talk about vulnerabilities. Well, what is a vulnerability? Vulnerability in this context is simply defined as a weakness in the code that makes your app, yes, your app, not secure. It's my iPhone. An app inside here might not be secure. A good example of vulnerability would be unsafe SSL implementations, which makes the app susceptible to man-in-the-middle attacks. Number two, what's a backdoor? A backdoor really just means that it's a feature that's undeclared, embedded in the code on purpose. Yes, that's right, on purpose. And a good example of this would be hard-coded privileged accounts that are not mentioned in the developer's documentation. Now, next step, we're going to go deep into the actual topic itself of black box testing and white box testing. But first, a brief mention over here that some of you might be interested to see how binary SAST takes place in real life. If you do, and you wanted to see how it worked out in terms of findings for one of the companies that is happily to share this, Schneider Electric, okay, please contact us at Athena Dynamics, and we'll be very glad to show, with their permission of course, how binary source code review was able to give them real value at Schneider Electric. Again, contact me, Ewen.Lim, EWEN.LIM at athenadynamics.com, and we'll be happy to set up a session just to share a bit more. Okay? Great. Now, how secure is your software? From black box to white box testing, right? Now, there are two basic application approaches to check for app vulnerabilities as well as backdoors. Black box, white box. Now, there's a certain hybrid combination of them as well that's currently being used today. But black box testing is also known as behavioral testing. It's a software testing method in which there are internal structures of the app that are actually being tested, not known to the actual tester himself or herself. Now, black box testing is named this way because the software program in the eyes of the tester is like a black box. You cannot see inside this black box. And the main advantage of black box testing is that you don't actually need a source code. But. This method isn't actually able to reveal as many vulnerabilities as you would need to use white box testing to find out the vulnerabilities of an app. And indeed, the white box testing has got very limited coverage. For example, you would never be able to review hard-coded lines, what we call time bombs in the cyber industry, via black box testing. The white box testing, though, looks inside the software that's been tested, uses that knowledge as part of the testing process. Okay? Think about that a moment. With this method, the maximum coverage is obtained, including hidden vulnerabilities and backdoors. The white box testing methods that you see on the market today have got the added disadvantage, though, of needing to retrieve source codes in order to actually perform the tests. So what we've seen is the emergence of innovative technology today that can transform a black box test into a white box test. You find this interesting? Now, if a source code is available, what these so-called screeners can do
for the apps is easily take it in as an input, do a screen of this, and show you the vulnerabilities, show you the backdoors that we shared a bit about just now. Now, different companies have done research on how the apps in, say, your iPhone today, like me, how vulnerable they actually are. Interesting stats. 70% of them use vulnerable pieces of third-party code. Almost 90% of them use HTTP for service data communication, which is a huge area that leaves them open to phishing attacks. And 20% of applications do not properly check SSL certificates at all, leaving you open to man-in-the-middle attacks. A brief glimpse of personal messaging apps in the Android Google Play Store would show you that many of them have got critical, even vulnerabilities that really need to look into. So if you want to get your data stolen, by all means, please open up one of these apps, connect to a public Wi-Fi, and you will be compromised in no time. For those of you like myself who love Apple really isn't that much different in this area. The same messenger apps on iOS also show a poor level of security. Now, a few benefits of using source code scanning tools in order to become more secure. Firstly, there's now technology on the market which allows you to actually do it without source code. In an era of COVID-19, in which everyone is socially distanced in between even countries, working in different time zones, this really helps, because there's now no need to request source code from a developer, but you can just obtain the files to be analyzed from the sysadmin or specify a Google Store, App Store link. Number two, no development skills needed. So there are a lot of tools on the market today that are designed for the CISO office rather than just developers, and you can then use very user-friendly interfaces in order to do your analysis. I've had a play with several of them. They're really good user-friendly ones on the market. And finally, really happy to say, a lot of your Friday evenings won't be spent investigating false positives, because a lot of the new tools have minimum false positives. Now, we're just going to wrap off over here with a couple of case studies, because these tools in the market today are used by real people. People like you, people like me, okay? First example that we have is a legacy audit system. And what we had is a situation in which, due to the fact that this legacy system was out, the source code was from a while ago, the company kept using this in their SDLC. Their CISO decided to check their legacy application, took a copy of the app from the sysadmin in the executable format, and threw it into their tool. Now, the app wasn't vulnerable, but what was discovered was a hidden internet connection with hard-coded IP addresses, sending it to an unknown host in Ecuador. And of course, this could have been routed to any number of other countries, leaving that data and the reputation of the company really open to malicious attack. The second and final case study is to do with dishonest developers, post-production AST, okay? Now, the big problem that some of the tools in the market solve today is that they understand that in the rush to get codes out into production, very often people take tiny snippets of code from GitHub, from Google itself, in order to actually develop their code quickly, rushing into production. And what this particular CISO was able to do is, after reviewing their code, screening it heavily, what they discovered is that the trim codes for testing had been rushed because people and its developers in that other market were trying to get and be eligible for their bonuses for meeting tough deadlines. All right? So using tools in the market, you'll be able to actually convert black box testing into white box testing, having it transparent and clear so you can avoid many of the problems that would come with data leakage of sensitive data, sensitive company information, even to a competitor, okay? And even exposure to legislation outside there, such as GDPR, which of course will be a topic for another day. Thank you very much everyone for your time this morning. And let's take a look at your scan results. Again, for those of you who would be interested in finding out more about our use case with Schneider Electric, we'll be delighted to share more about what some of the exciting findings really are. Thank you, everyone. Let's now get straight to the scan results.
So let's take a look now at our latest findings. Just to recap for those of you who have joined us midway in our speaking session, one of the tools that we are looking at today, part of the new generation of next-gen binary SAST tools is Solar App Screener. Now, as we know, all apps are vulnerable due to fast code development, fast production. CI/CD today often leaves no time for code analysis, which is why the vulnerabilities in your app have become very, very common targets for hacking. And as of now, successful attacks count up to 90%, some people estimate, of all cybersecurity attacks. The reason why this is really quite harmful is because many of the apps contain two things: payment data, including banking details, personal information, including your photos or your company's competitive information. All right. And if your app's been hacked, this will lead to financial loss, reputational risk, even the loss of the customers that you've worked so hard to get. So this tool actually helps you to find vulnerabilities and backdoors in the apps, source codes and binary codes, and protects your data from a hacking attack. Now just take a look at this. So this SAST tool's graphical UI basically is a very easy to understand web server interface with a secure connection via HTTPS. And looking at this, let's see how it looks like based on one of the open source apps, which is I've chosen the Lightning browser. Just take a copy of a link from the Google Play Store as it is, paste it into our cloud-based UI. And over here, check this out. One of the main features to be mentioned is our detailed customization. User U can basically select, unselect the criteria to be shown and have this reflected in an easy to understand report. And we'll keep all of them as it is. As you can see over here, the scanning we've got reflects the vulnerabilities, 4 types. Critical, of course, medium, low, info. A quick look at the detailed results and you can see what's been found. Now over here, we've seen that for Lightning browser, we found 888 vulnerabilities in total. Ooh, 888, not exactly very fat, as we say in Mandarin. Okay, because of course it shows also thousands of vulnerabilities, and it's nearly impossible, very hard to actually fix all of them at once, or even to check them all. And for this, part of the usefulness of this tool is the fuzzy logic engine. And this is a unique filter helping to sort and eliminate the false positives. Now, after applying it, what we have is only 755 vulnerabilities, almost 100 less than what you had initially. And what this means for you is your developers can fix this as a first priorities. Now, the vulnerabilities are displayed with the following criteria: description, some of the example, recommendations, remediation. Some of you have asked just now during our session, how can you fix it? Well, it's over here. Also, links where you can read about them in the most trustworthy sources, as well as classifications according to all your standard awareness documents for your dev guys and your web app security guys. So CWE, OWASP, PCI, DSS, HIPAA, so on and so forth. Next, the tab trace helps to trace the vulnerability and shows the place of it in the code itself. The next tab is vulnerability management, also a very useful tool for customization. Now, let's pause here for a moment. Let's say you don't really want to count some vulnerability as a critical one. So, like me right now, you mark it as low. And here in the next scanning, it won't be shown among your critical ones. Also, for those of you who have messaged me, yes, you can create a task in Jira through the user profile. All right. Now, after all this is done and your scanning is completed, you get a detailed report of the results and your clickable links. Feel free to customize your report. A lot of you like customizations, all you Android users I know, and of like that, certain parameters can also be deselected if needed. Okay, this particular tool is pretty interesting because it says, yeah, it can scan 35 languages. I think that's quite interesting, especially for those of you who have got a lot of legacy languages like COBOL, C++. Yep. Great. Well, to get a greater understanding more about how tools like this and other tools work, give us a buzz, write to us, and we'll be happy to share more about some of the tools in the market. Thanks, everyone.